Most popular entries are question mark. And now we come to the next question. What fills up these question marks? How do I actually determine what goes here?
Now these entries get their numbers by something called as collaborative filtering. Imagine you and your friend likes the same thing. The same films, the same reels, the same songs, the same movies. Now a new reel comes out and your friend watches and loves it. You have not watched that reel yet. The algorithm now notices that your row and your friend's row look very similar to each other. So there is a good chance that you love this reel too. And this is the idea of collaborative filtering. But what does being mathematically similar actually mean here? Your preference vector is basically an arrow, not in a two-dimensional or three-dimensional space, but a multi-dimensional space where every dimension represents one of the pieces of content online. And in that imaginary space where each dimension is one piece of content, this arrow points specifically towards what you like. Now to measure how similar our tastes are, mathematics does something called as a dot product. Say your scores in some particular entries are 0.9, 0.2 and 0.5. Mine on the same three pieces of content are 0.8, 0.3 and 0.6. Then the dot product becomes 0.9 into 0.8, which is 0.72, 0.2 times 0.3, which is 0.06, 0.5 times 0.6, which is 0.30, and the total comes out 1.08. Now higher this number is, the closer our preference vectors are to each other. And a low number would mean that our arrows are not that close, might be pointing in different directions, and so our tastes are not very similar. But here's the part I find beautiful. A dot product is not just a mathematical calculation, it is the geometric idea of projection. How is one arrow casting its shadow on the other arrow? If our two arrows point in exactly the same direction, the shadow is longer and thus our dot product is high. Our two arrows do not have that much similar in them, then the shadow formed is shorter and sometimes even zero, and sometimes even negative if our two vectors or our two arrows are pointing in two different directions. So now the matrix knows who's similar to you and can fill your unknown entries by seeing how these people similar to you interacted with those pieces of content. But understand, the matrix only records your past and cannot predict your future. For predicting the future, we need something which does not just keeps looking at your past but treats every action you take as a probability map. And it turns out this structure was first used to study whether letters in Russian poetry followed a pattern or not. And that's for the next reel. Follow and save this one because math only makes sense in order.